Caroline to me. So can you guys all see me on the screen? I know it's a horrible thing to have to look and see me during this, but bear with me. This is how I live now on this sofa. So you guys open up your notes, and you're flipping back and forth, aren't you? Okay. Thumbs up if I'm the main person on your screen right now. Okay. So in your notes, there's I gave you two packets of notes. One of them that says types of reaction, and it has kind of a spiel. Caroline, would you mind reading out loud for everyone the beginning, the opening with that, and then I'm going to move on from there. I'm going to present this to everyone, so you're on the screen right now.
Okay, here's the deal. There are tons of reactions, millions and millions of them, so there is no way that we will ever be able to know them all. However, we are able to break them down into 5 main groups. The thing to remember as you go through this section is that you are really only memorizing 9 or 10 new things.
Okay, so the truth of the matter is there are literally trillions and trillions of reactions, trillions of them. And I'll put you back onto me. Hopefully you can see me here. I'm going to unpresent. There. So there are trillions of reactions, and we don't want you to memorize thousands, never mind trillions of them. So what we're going to do is I'm going to break down the types of reactions into 5 main groups. This is kind of like what we did with Lewis structures. Remember how we did the 3D structures, and we broke them into templates for like linear and trigonal planar and tetrahedral. We're going to do the same thing right now with reactions. Now, there's a couple things you need to bear in mind. One is you just spent a bunch of time with Mr. Brader, if I'm not mistaken, doing balancing equations. And the thing you need to remember with balancing equations is that every time you write a formula, an ionic formula or a covalent formula or anything, the formula has to be balanced. Remember how we did balancing charges? So if I had a 2+ and I had a minus, we had to add 2 minuses to balance them off. And then when you did the balancing equations, we need to make sure that all of our atoms had the same number on each side. Now, that's incredibly important. So as we're doing all of the reactions that we're doing in this section, it is really important to remember that you have to make sure that you have balanced correctly your equation, or else your equation is no longer useful to us. Kind of like the worksheets you guys have been doing where you put coefficients in front of each of the individual compounds. That's something that I expect you to do. The second thing I expect you to do is this. If you can skip, Caroline, if you can skip the reading, the next point, and see where it talks about Hun and the halogens.
Halogens, like synthesis reactions?
Up above that, above that.
Oh, okay. Oh, yeah.
Something about hydrogen, oxygen, Brinkelhoff.
Oh, yeah, okay. There are some elements that when they are by themselves, they always exist in pairs. Remember Hans and halogens or Brinkel.
Okay, so here's the thing. If I ever write down an element for you, like carbon, you're going to write down the letter C. If I write down aluminum, you're going to write down the letter Al, or sodium, Na. The only time you're going to write Na plus or Al3 plus or the charges like we did before is if those things are part of a compound. So if I just gave you the statement, aluminum plus oxygen, you'd write the formula for aluminum as Al because that's what aluminum is, Al. But oxygen is unique. Oxygen is one of 7 elements that when they're by themselves, they always exist as pairs. We call those diatomic molecules. So if you take a look at Brinkelhoff, Brinkelhoff is actually the acronym for the letters for each of the elements. So Brinkelhoff, Br stands for bromine, Br, I, N, Cl, H, O, and F. All of those, whenever you write them by themselves, you have to write them as 2. You'll never write O, you'll always write O2. You'll never write F, you'll always write it F2. Hun and the halogens is another way of doing it where it means Hun, H-O-N, so hydrogen, oxygen, nitrogen, and then all the halogens, that group, all of them require pairs. Can I give a thumbs up if you understand that you ever see one of those 7 by themselves, something plus oxygen, something plus chlorine, something plus fluorine, you have to write it as F2, O2, Cl2. Can I get a thumbs up if that makes sense to you? I don't see all the thumbs, but I see most of the thumbs. Okay, so that leads us to reactions. And in just a second, I'm going to get to you, Caroline, and you're going to become a very busy person. But right now, I'm going to share with you an anecdote because, you know, who doesn't enjoy an anecdote, right? It was my 2nd year of college, I believe it was. And what they had every week is they had, actually it wasn't every week, it was every month. Every month they had, once a month, they had a talent show in the cafeteria. And I use the word talent in the loosest way possible because they were terrible. They're absolutely, I'll tell you how terrible, here's how you can gauge terribleness. One of the acts played a kazoo. Now, I don't know if you've ever heard a kazoo before, but there's no entertainment value ever in a kazoo. It is a terrible, horrible, I don't even call it an instrument. Maybe you don't even know what a kazoo sounds like. It's that bad. It's a wretched sound. Someone played that, right? So me and my group of mean, we used to always sit down and we would watch these and we laughed ourselves till we cried. I mean, it was such an entertaining thing. Looking back now, I probably shouldn't be sharing this with you because that makes me kind of a horrible person. And I also realize I'm videoing this so other people can watch how horrible I actually was. But we enjoyed these shows so much, not because of the joyous talent, like we're probably going to see at the musical, but because they were so dreadful. So imagine this. Imagine that we're all sitting there just salivating at the opportunity to just rip some of these poor kids apart. And the announcer says, and now for your listening enjoyment, Mike and his magic fingers. Yeah. So I don't know what comes to your mind when someone introduces themselves as Mike and his magic fingers, but there's so many ways you can go with that. And all of them are just incredibly funny if you want to make them that way. So we're waiting for him to come up and we are already like making jokes about Mike and his magic fingers and what he might do with the fingers, et cetera, et cetera. It was pretty poor. But it gets better. So as he comes up on stage, he's wearing a top hat. I don't know the last time you wore a top hat was, but I'm guessing most of you at school have not worn a top hat. And in addition, he was wearing a cape. Now, I'm all for capes if you're part of the superhero family, or perhaps a vampiric villain of some kind, or maybe even if you're like part of the British royal family, wear a cape. But in general population, you probably shouldn't be wearing a cape. So he gets up there and we're already just laughing and whatever. Again, horrible human beings that we are. He takes the mic from the announcer and he puts it on the stand and then he just stops and he stares at us. Just stares us down. And we're like watching him and we're like, yeah, this is the area he's like using some sort of mind trick. But believe it or not, we all just quieted. So he gets completely quiet and we're like, okay. And we start listening to him and he looks at us and he does this. And we're like, did he just do like finger puppet thing? Did he just like make two fingers become one? And he's all like, whoa. And then he did things like he changed his pitch and key and was like, dun, 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 and he was like doing all this stuff. And at first we're like, this is the dumbest thing I've ever heard. He was doing things like, you know, you pull your finger off, and then he did like things where like he ran his fingers. I can't even, this was before the time of YouTube, or I'm sure that it would be one of those major hits. But anyway, he did his show for like probably 5 minutes. And when he got done, it's the only time in the history of all of my attending college that we gave someone a standing ovation. So Mike and his magic fingers, he probably has no idea that in the last 20 years, I've used his finger puppets as inspiration for me teaching reactions, but that's what I'm going to do. So here's what we're going to do. We're going to break down all the different types of reactions into 5 essential finger puppet templates. So template number 1 is this. Anytime you see a reaction and you have one thing and you have one thing, you only have one option. The only thing you can do is put them together to make a compound. So when you walk up on a reaction, and all the reactions that we're going to give you, they're only going to have the stuff on the reactant side and then an arrow, nothing on the product side. So if you see this, you're going to go, oh, that's a single thing and a single thing. What's the only thing I can do with them? Put them together. For those of you that didn't see my lightning quick reflexes, poof, right? Changes into a compound. This is a synthesis. We're going to look for this, though. So we see this, we know we have a synthesis. So now we're going to turn over to Caroline on the board. So what I want Caroline to do is I want you to write A at the very top of the board to the left, as high up as you can write. And let's start, make sure that you're using either black or blue because, yeah, wonderful. Because we discovered that red and orange or whatever, it's pretty terrible. So as high up on the board as you possibly can write, a little bit higher, you write A plus X goes to AX. Okay, that right there is a sample of the puppet show I just showed you. Can you guys, by the way, for those of you that are viewing this, are you seeing her as the main screen person? Can you give me a thumbs up if you see it? Okay. Okay, he's still sleeping. Okay, now what that means is anytime I give you two individual things, you're gonna put them together. So let's do a practice one on this one. Let's write sodium plus chlorine and an arrow. So actually write the word equation. Sodium actually write use the plus sign. Sodium sodium plus chlorine and then an arrow. Okay, so if you look at that right now, isn't that two individual things? Show me the puppet show that I showed you before. Okay, see that right there? If we mirror that, isn't that an individual element? Put one finger on the sodium. And isn't that another individual element? Put another finger on that. So what is the only thing we can do when we have two things? Show me the puppet show. Caroline, you're going to show it for everyone. You're going to show it to put it together and form one compound. So on the other side, we're going to put an arrow and we're going to write the compound that it shows. So it's going to become sodium chloride. Now, I want you to notice something here. See how we had on the left-hand side, we wrote them as elements, and on the right-hand side, we wrote it as a compound. Do you notice how the ending on chlorine, we change it to chloride? That's what you have to do whenever you put things into a compound. Can I get a thumbs up from everyone if that makes sense? If you need any clarification, I can give it to you. So right now, there's going to be 4 things you're going to do on the test when I'm asking you to do problems like this. You're only going to see the words that she wrote on the left-hand side, sodium plus chlorine. That's all you're going to see, and an arrow. You're going to get 1 point for writing sodium chloride on the right-hand side. You're going to get a second point for writing that this is a synthesis. So can you write on the left-hand side of the sodium, can you write the word synthesis?
Here?
Yeah, please. And in fact, up above with the A plus X goes to X, can you make that, can you write synthesis as well? And where are you going to the here? That's over there. Okay, so now watch. You've gotten 2 points if you're doing this on your own. You got 1 for the name, and you got 1 for the formula. Now we have to write the individual formulas down below. So underneath each one, we're going to write the actual formula. So what's sodium? Na. Na. Now I'm delighted that she said Na and not Na plus. The only time it's going to be Na plus, I saw someone wave, but I'm not sure who just walked by.
Mr. Kelly.
What's up, bro?
All right. Wonderful. And for chlorine, you're going to write Cl2. Now, tell me why I wrote Cl2 instead of Cl. Anyone here? Unmute yourself and tell me why we wrote Cl2 instead of Cl.
Is it because it's part of the
diatomic?
Yeah,
Absolutely.
the Brinkhoff thing?
Yep, Brinkhoff. Remute yourself. That's exactly why we wrote Cl2. So if it had been anything other than Cl2 or chlorine, then we would have just written Cl. Now, put an arrow next to the Cl2, please. Okay, now watch. This is kind of a big deal. Whatever's happened on the left-hand side, so point to the left-hand side of that equation right there. Anything that's happened over there, we don't care about when we get to the right-hand side. So look on the right-hand side. What's the only formula we have up there? Isn't that sodium chloride? Okay. Doesn't this look an awful lot like some of those worksheets that we were dealing with to try and write compounds out? So if we want to write the formula from that, we need to know what the charges are for that. So can you write above sodium, can you write Na plus above it? Na plus. And then can you write next to it, write Cl minus? Right next to the Na plus. Cl minus. Okay. This is kind of like, remember last section when we were trying to write formulas from names, and this is on the last test that some of us did great on, some of us not so well. You scoot a little bit to the right here so the camera can see, right? Yeah. So watch. Whenever you see a compound on the right-hand side, it doesn't matter what was written on the left-hand side. We're just going to balance off the charges to write the new compound. So don't I have an Na plus and a Cl minus? Aren't they the same charge? So can I just smush them together to write the formula? Can you write NaCl down below sodium chloride, please?
NA what?
NaCl.
Why do you put the plus and minus? What? Why do you put the
Yeah,
plus?
like chlorine.
Anna wants to know why you put the plus and the minus.
Oh, because we have to figure out how to balance the charges. So if it wasn't an Na plus and a Cl minus, let's say it was Mg2 plus and Cl minus, the formula would be MgCl2. So you kind of do me a favor. Let's just remind you of something. Can you down below, like, just this is not part of the problem. Can you just write down Mg or all right, magnesium chloride? Just write the word magnesium chloride. Okay, so this is kind of like the ionic formula worksheets we were doing before and the quizzes and even the test. Whenever you see a compound like that, your job is to balance off the charges. So do me a favor, right underneath magnesium, can you write Mg2 plus? And right underneath chloride, can you write Cl minus? Now, don't we have a 2 plus and a minus? And if we wanted to balance it off, wouldn't we need 2 of the Cls to balance off 1 of the Mgs? Now, the other way we can do this is by doing crossover. Can you take the 2 and cross it over to below the Cl? And can you take the imaginary 1 and drop it down next to the Mg? Okay, so if that's the case, then the new compound, we write it out, wouldn't it be Mg, right down below, MgCl2? Okay, so I'm not sure who it was that asked that question, but that's exactly what we're doing up above with the NaCl. Put your finger on the Na plus and the Cl minus, please. Okay, see that right there? That we're doing the exact same thing because we have a plus and a minus, but in this case, there is no crossover because we have the same charges. They're already done. So we just write it as NaCl. Any more questions on this? Okay, so let's erase the magnesium chloride thing down below and let's come back up to the equation. So right now, you've written all of the correct formulas. So scoot to the side there just a little bit so everyone can see through there, the NaCl. But is that a balanced equation?
No.
I'm asking anyone here. Is that a balanced equation?
No.
You can type in yes or no. Okay, I see no's. It's not, right? Because if you take a look, don't we have one Na on one side and one Na on the other side? And that's good. But don't we have 2 Cls on the left-hand side and only 1 Cl on the right-hand side? So we have to use coefficients to balance off, right? So let's put a 2 in front of the NaCl on the right. Do you see how that 2 gives us 2 Cls, which balance off the Cl2? But doesn't that also give us an extra Na? So what do we have to do to balance off that extra Na?
Add a 2.
Put a 2 in front of the Na on the left-hand side. And that's your 4th point for balancing. Any questions here? Let me give you one on your own to do. And right now, obviously I'm giving you synthesis reactions. But if I wasn't giving you synthesis reactions, you need to be able to know what type of reaction it is by matching it up with the puppet show. I do not know. That's a really good question, Hannah. It's not going to be any time soon. And by that I mean at the earliest it'll be the end of next week, but I don't think it'll even be then. So let's change this equation, erase everything here, and I'm going to give you guys just the reactants, and I want you guys on your own to write what the products are going to be, and then no, leave that. Actually, take what you just wrote there. Let's write it as far over on the right-hand side as you can. We're going to make a little table for all the things that are the templates. So up above, and let's a little bit lower because I can't see that on the screen, and over to the right a little bit more. Okay, can you write a little bit farther over to the right? Okay, right there. Can you write A plus X goes to AX? Is that an arrow or is that an equal sign?
Whoops.
Just kidding.
Okay, and then on the right-hand side, can you write the word synthesis? So anytime that we have 2 individual things, that's what we're going to have. So let me give you another example on this. Can you write down in the middle of the board now, up above. Yeah. This is right down. Let's go with zinc. Zinc. Let's write the word zinc. This is a word equation. Zinc plus oxygen and an arrow. Okay, I want all of you right now to try and solve this equation. You can try it on the board by yourself if you want. And if you want, I mean, try it, even if you're wrong, that's okay. Thomas, are you asleep?
No.
Okay. That is one of the weirdness about this. I see all of you on my screen. Okay. I want on the right-hand side, we have to write the word equation. So show me the puppet show again. What happens when we have two individual things? Show me the puppets. You're puppeting for me. Two individual things form one, right? So we have zinc and we have oxygen. So what two things are they going to form? They're going to form one single thing, right?
So it's ZN or like the.
It's going to be zinc, but we're writing the word equation only. Can anyone want to jump in here? When we put zinc and oxygen together, we're going to have to knock off the ending of the oxygen. What are we going to end up with as our formula?
Zinc oxygen. Oh, zinc oxide.
Nice. Does everyone see how the zinc plus the oxygen, we just put it together. Can you scoot a little bit to the right so the students they're watching? Yeah. The zinc and the oxygen put together, we drop the ending of the oxygen and add IDE.
Take the orange and underline I.
Do you always do that? Do you always do the I?
IDE, yeah. You always drop the ending and add IDE. Yeah? So once you've done that, then it's a matter of writing the formulas for everything. Oh, you want to get another point, so can you put synthesis on the left-hand margin of that, please? Right to the left of it. Yeah. Okay. So now we have to write our formulas down. So on the left-hand side, aren't they just elements? So let's write those down. In essence, I'm trusting, good job. And what's oxygen? It would be O, but yeah, isn't it part of the Brinkelhoff? Can I get a thumbs up if everyone saw that? Everyone understands why it's O2 and not O? Okay, good. And then let's move over to the side. Now, once we have zinc oxide, this is just literally like we're writing a formula on a test. So you have to balance off the charges on your own. Isn't zinc a Zn2 plus? And isn't oxide on the right-hand side? Your right-hand side. Everything's good on the left-hand side. We want to write down the formulas here. So Zn's a 2 plus, and isn't oxide a 2 minus? If we have a 2 plus and a 2 minus, can't we just squish them together? So what's my new formula going to be then? ZNO. So we're gonna get rid of that, and we're gonna just write ZNO in its place. She wrote that down there just to see how we got to that, but ZNO is going to be. That's our equation. Now, the question we have to ask ourselves is that a balanced equation?
Not, no.
What are we missing here for it to be balanced? Yeah, so we have two O's on the left-hand side, right? We only have one O on the right-hand side. And the only thing we can do to try and balance off, isn't it to put coefficients? So what coefficient are we going to put in front of the ZNO?
2.
2?
Oh, right. No, you put a 2 there. Yeah, you put a 2 here. And then also 2. Right?
Good. So if you put the 2 in front of the ZNO on the right, that means you have 2 zincs and you also have the 2 O's, and this is a balanced equation. That gives you your 4th point. Any questions on this? Okay. All right. Now glance at me for just a second. Cozy. I'm going to jump off of you for just a second, and I'm going to come back. Can you guys see me right now? Okay. All right. So this is a synthesis reaction. Two individual things form a compound. The exact opposite of that is what we call a decomposition. And decomposition is when we have one compound and it splits apart into two individual things. So if you look at it, here's our puppet show. Individual compound by itself splits apart into two individual things. Isn't that exactly the opposite of a synthesis, which is two individual things form one compound? Here we have a compound splitting apart into two individual things. So on the board, can you write AX? So on the right-hand side, under synthesis, can you write AX and an arrow, and then write A plus what plus X? And can you write the word decomposition?
Decomposition.
Decomposition. Okay. Now, do me a favor here. Put your finger on the AX. Do you think that AX wants to break apart? About my question is probably leading you on this one. Do you think that AX wants to break apart? Shake your head no. It doesn't want to break apart because the whole point of AX forming in the first place, whenever it formed, was so that it would be a stable compound. So what we have to do is we typically have to force it to break apart. And so the way we force it is we usually like zap it with electricity, which we call electrolysis, or we heat it up. So what you should see whenever we're doing a decomposition reaction is you should see a compound by itself and then an arrow, and on the arrow it should say either electrolysis or heat. But it's really hard to do that with Microsoft Word. So just understand that in order to break up something that's already formed, you're going to require some energy of some kind. So can you erase to the left all that stuff that's been written there? Okay, and I'm going to give you a sample problem that we're going to work through on this one. So let's go barium fluoride with an arrow. I see a disembodied hand that just came there. Who is that?
That's Mr. Kelly.
Who is that? That's Mr. Kelly?
Yes.
Hi. Hey, Mr. Kelly. How's it going? Is he subbing for you today? Or is he just hanging out?
I want to see. I want to learn from you.
That's awesome. Okay, so all you guys can see this right now. Isn't that a compound just sitting there by itself? In fact, Caroline's going to model for you with the puppet show what that looks like. What does that compound just sitting there by itself look like? Start with two fingers on one hand, together, up. That's what it looks like, right? So put the single compound up again, okay? Like a peace symbol, but put your fingers together. Okay. Anytime that you see a compound like that, every single time you see a compound like that, there's only one thing you can really do. What is it? Help me out from the crowd here. What's the only thing you can do if you see a compound by itself? Unmute yourself and answer.
Break it apart.
Break it apart, right? I don't know if anyone else said that in the classroom or couldn't hear. Break it apart. So doesn't that mean in this case right here, let's look at, scoot back so we can see this. Barium and fluoride. Don't we want to separate it apart? So what two things is barium and fluoride going to separate apart into?
Barium plus fluoride.
Yeah, except we don't call it fluoride when it's by itself. What do we call it?
Fluorine.
We call it by its regular name, fluorine. It's only fluoride when it's part of a compound. So write barium.
Okay.
Yep. Okay. Does everyone, I need thumbs up or thumbs down on this one. Does everyone see how the reason that it's called fluoride on the left-hand side is because it's part of a compound? And the reason that we call it fluorine is because it's by itself on the right-hand side. Can I see a thumbs up if that makes sense to you? I can see everyone. Okay. So that's our formula. That's how it's supposed to be written, right? The only job we have left right now is to write what the actual formulas are. I like how you underline that. That's good teacher mode. You have teacher genetics in you. I can see it. So again, if you look on the left-hand side, isn't that an ionic formula that we've seen so much of, just the way it's written, barium fluoride? So we're going to have to know what the ions are to get to the actual formula. So isn't barium Ba2+? And isn't fluoride F minus? If I have a Ba2 plus and an F minus, can I do a crossover to end up with the correct formula?
Yeah.
You show me, you can do it underneath it if you want. Underneath. Yeah, good. That's good. That's totally fine. And then the 2 goes there. And then underneath, can you write the correct formula? F2. Does everyone see how we did a crossover there? Now, put an arrow next to that, please. And on the right-hand side, now we've broken it apart into the regular elements. Those aren't ions anymore, so we just write what the formulas are for each one. What's barium? The formula for barium?
Ba.
Ba, just Ba. Good job. And how about for fluorine? Now be careful on this one. Normally we'd say F, but someone jump in here.
All right.
Someone help her out here. Someone unmute and tell me, why is it not F that we're adding to it? Erase what you've written there, please. And look at the formula. So on the top here, see how we have barium written and then it says added to fluorine. So when you write barium, you ready to put it down, make a plus sign next to it. And then we have to write what the formula is for fluorine. Now, normally fluorine is just an element, right? So when we, on the periodic table, look up what fluorine was, and we say it's F, right? Write an F down. But remember in the beginning of my notes today, what did I say? If you ever hit one of these 7, can anyone help me out here? Make me feel like I'm not a total failure as a teacher.
F2.
Okay, whoever said that, tell me why. Unmute yourself and tell me why.
Because it's part of the brain cloth.
I applaud you. That's perfect. Thank you. So because it's part of Brinkelhoff, we can't write it as F2. Does everyone see this here? Because that's one of the biggest tricks. Because watch, if she writes that as F, do you realize that we're not balanced? And the formulas are not going to work. So it might even be worth writing. Can you on the very top of the page just write, or somewhere on the side, write Brinkelhoff's elements down so we can just point to it?
Like on here. Wait.
Yeah, sure. Somewhere on there, just so we have it. So maybe write Brinkelhoff. So BR2, I2,
N2, CO2, H2,
So you're gonna have to kind of memorize that just to remind yourself that if you ever see those by themselves, those always exist as a pair. Yeah. Now, side note here: did Mr. Braithwaite give you any polyatomic ion quizzes or no?
No.
No. How do you guys feel about polyatomic ions right now? Do me a favor. I'm going to look at you right individually. So, and be honest, because this could end up coming back to bite you. I'm going to put my glasses on even so I can see you here. On a scale of 1 to 4, 4 being I know polyatomic ions so well that I could take quizzes from here to ever and I would get a perfect score every time. 1 being I know them terribly. Where do you fit? 1, 2, 3, or 4. Hold up in front of you how many fingers you feel. Honestly, feel. Okay. Okay. I'm now opening up Jacob, Hannah, Emily. Okay, so what I'm seeing a whole lot of is 2s. Is that a fair assessment from where you're standing right there, Caroline? So we need to rectify that. And you're not going to like me on this at all, but we're going to have a polyatomic ion quiz next class period. And it's literally going to be me giving you just like we did in the previous test, remember? The polyatomic ions, I'll give you the name and give you the formula and vice versa. Don't look at this as like another quiz that's going to hurt you. View this as a quiz that can help your scores. I'm begging you, spend some time with your polyatomic ions because we need to know them. All right, so coming back to this here. We're on decomposition. Agree? And a decomposition is always 2 things separating out to form, a compound separating apart to form 2 individual things. We're going to shift to something else right now. So erase everything there. And we're going to do something called a double replacement. So on the right-hand side, can you write AX plus BY goes to AY plus BX? Okay. So what you're seeing right there is a double replacement. And I don't know if it's a thing anymore, and maybe it was never a thing, but for a while, country dancing became like really popular. Like if you went anywhere to any place, there's always like line dancing somewhere or another. Is that still a thing, line dancing? We're in Texas, right? So I'm not relating to any of you. All right. So back in the olden days, there was a thing that we used to do called country dancing or square dancing, they used to call it sometimes. And what was cool slash, now that I'm thinking about it, not cool at all, is that you'd have someone calling out what you were supposed to do in advance of every step that you did, which I think nowadays would be really uncool. And one of the things they used to do is something called a do-si-do or whatever. And they'd holler it out. It kind of like be country rapping, which is just depressing in all ways. But he'd kind of be like, take your partner, swing her around, blum, 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 do-si-do. And what that meant essentially was swap partners. So if you take a look at the double replacement that I've shown you, and can you write double replacement in the right-hand margin next to that? I realize that I'm not seeing any of that on the screen, unfortunately.
I can move it a little bit. Is that good?
Yeah, that's perfect. Okay, write double replacement next to it. We notice that essentially, if you keep your eyes straight, think of the A and the B as staying still, and the X and the Y, they just swap places. Is that not an accurate assessment? So look at me for just a second here. I'm going to switch it over to my own view here. Okay, so watch. Anytime you see a compound and another compound, so two compounds sitting next to each other, what they actually do is they actually swap partners. Now, in essence, they have a compound and a compound, and it forms a new compound and a compound. But that's the worst puppet show ever. What actually happens is that the original partners, they stay the same, and these guys swap places. So what ends up happening is that these two are together, and then what they do is they become this, which is, again, a terrible way of doing it. So let's look at the board, and the best way to give you an example of this is to actually do a problem on the board. Can you shift it over slightly to the left-hand side again, please? Okay. Can you write this down? And you're going to need a little bit of space. So start as far over to the left as you can and still being in camera. Let's go zinc chloride plus sodium carbonate and an arrow. Now, Caroline, for you, those of you who are watching at home and are watching on your screens, is going to demonstrate for us what template that actually is. Isn't that a compound and a compound together? Can you show me the puppet show for me, please? Of two compounds together? Yeah. It's just, yeah. That's awesome. Just show the before, though. Show just the before they actually interact. Show the individual compounds by themselves. Yeah, that's perfect. So that's the keep him up for a second, please, Caroline. What? You did it perfectly. Okay, so hold up the two compounds like you're doing before. Okay. Anytime you see a compound and another compound by themselves, the only thing you're going to do is swap partners. And so what we're going to do is we're going to take the tail ends of both of them and switch places. So can you go up to the board and can you just put like an arrow, like a loopy arrow from the chloride to the carbonate and then from the carbonate to the chloride? Yep. Perfect. Do you understand that we're just going to swap places? Can I get a thumbs up if you're understanding that's what we're doing? Now, what we're going to do is we need to write a word equation. And unfortunately, we don't have very much room. Is there any way you could write what you just did there really a lot smaller, like down, so that we can actually have enough room to write the two of them that may go a little bit farther to the left? And actually write I only want the formula. So write zinc chloride again, but really small enough so we can, yep. Plus sodium carbonate. Now have the arrow. Okay, now watch. Won't the carbonate and the chloride switch places? So what's my new compound on the left-hand side going to be? It's going to be zinc what?
Carbonate.
Zinc carbonate?
Carbon.
Carbonate. Carbonate, because it still says it only becomes "-ide" when it's an individual element to begin with. Plus sodium chloride. Okay. Does everyone see that all we did was we kept the zinc and the sodium in the exact same place, and we just swapped the partners? Can I get a thumbs up if everyone sees that? If you did not understand, thumbs down, but I need to see a response from all of you, please. Okay, thumbs up, thumbs up. Good, good, good. Okay, so now look at this. Isn't this essentially just 4 ionic formulas now? So you get 1 point, and I'll be honest, the naming, the word naming on the product side is actually probably the easiest when you're dealing with double replacements, because all you do is you just swap the tail name to the ending name on both of them. You should write double replacement or DR to the left-hand side to get a second point. So on the left-hand side of zinc chloride, can you just write DR? That stands for double replacement. And now we need to write all the formulas down. Now, here's where, remember I emphasized how important it was to know your polyatomic ions and how important it is to be able to write formulas. And this is why. Because what we're doing right now is we have to balance off each of those equations. So underneath the zinc and chloride, can we write the formulas for each one of those? So wouldn't zinc chloride be Zn2 plus and Cl minus? And when we cross those over, what do we end up with? Right, ZnCl2 underneath it. Is there a 2 there? I can't really tell. Cl2 down below. Down below, not yeah. Do you see that all we did right there is we just crossed over the 2 and the minus? And then for sodium and carbonate, don't we have Na plus and CO3 2 minus? And again, when we cross over, when we end up with Na2CO3?
Na2CO. Oh, CO.
Good. Arrow. And then let's look on the other side. Don't we have zinc carbonate? Wouldn't that be a Zn2 plus and a CO3 2 minus? Up above. Do it up above where you did before. Because that where you're writing your line, that's your final finished product. We're trying to write the individual parts right now. So right there, it's going to become good. It's going to be Zn2 plus and CO3 2 minus. What happens when we have a 2 plus and a 2 minus? Can't we just squish them together and make it ZnCO3? Plus, what's the last compound that we have? Isn't it sodium chloride? So up above, can you write Na plus and Cl minus? And if we balance it off, wouldn't that give it just NaCl? Now, you've written all the correct formulas, but let's put pluses in between each one, yeah?
Yeah.
And put an arrow down between the two, the left and the right-hand side.
Right here?
No. Go on the left-hand side. Yeah, keep your arrow there, and then put a plus between the ZnCl2 and the Na2 here on the left-hand side. On the left-hand side, you need a plus in between there. Okay. Now, just so you're aware, put your finger on the second row of things you just did. The second row right there. Okay. That's your actual equation. What you did above, point to the charges above. Right there. Yeah, right there. What you did right there, that was just to help you get to the formulas underneath. Do you understand this, class? I don't need to see that upper line. If you can do the formulas in your head, all I really want to see is the line below. Can you put your finger on the line below? That's the equation I need to see. Now the question is that a balanced equation? Do we have the same number of atoms of each kind on both sides? What answer do you have to that?
No.
Well, let's take a look. I have one ZN. Let's put your finger on the first compound there, ZnCl2. Don't I have one ZN on this side? And how many ZNs do I have on the other side? One, right? And then put your finger on the Cl right there. Don't I have two Cls? How many Cls do I have on the other side?
All right. One.
On the other side. So put your finger right there, Cl2, and then all over there. Don't I have just one? So in order to balance it, mustn't I put a coefficient in front of the NaCl over there? So I have to put a 2 in front of that. You might want to erase the NaCl and leave a little bit of space to put a coefficient in front of it. Now, did that balance off everything else? It looks like the two NAs balance off and the CO3 balance off. That's your fourth point. Any questions on this? Okay, I'm gonna have you guys do one more on your own. So erase everything here. Caroline's gonna get the help of Mr. Kelly if she needs it, but she's gonna try and do it on her own as well. You're gonna have to write the formula probably the word equation as far over the left as you can and pretty small because we're not gonna have you saw how much space we had last time. Let's go with this. Let's go with manganese, Roman numeral 2. Nitrate. My cat just decided to stroll by. Plus aluminum chlorate and an arrow. All right, all of you right now, take a moment with the person beside you, and I want you to write the overall word equation on the right-hand side and then the overall balanced equation underneath. Go. If someone wants to help you on the board, they can. I'm not going to help you right now.
Now you do the process. You can talk and show that you remember. The steps are the same.
Which one's manganese again? Is it ML? I forgot the Roman numerals, but it was for like charge. But
Caroline, on the right-hand side there, you're going to write the word equation, so you don't have to worry about what the formulas are yet. You just need to swap partners. So wasn't manganese originally with nitrate and wasn't aluminum originally with chlorate? So what's manganese new partner going to be?
Chlorate.
Yep. And what's aluminum's new partner going to be? Yep. Good. By the way, as you realize, we're going to be using your laptops for the entire class. So you might want to start bringing your chargers and making sure that you're charged up before class. Okay, so you wrote that, but now you have to actually write the formulas down for each one. The rest of you guys right now, I'm watching you right now. I need to see you guys trying to write this out. The only reason you should have your head up is if you already finished the problem. Right now, you should be working with the partner that's next to you or someone that's next to you. And Lindsay, have you disappeared completely?
You to the bathroom, I think.
Okay.
That's the 2 means 2 plus 2.
Trevor, have your audio issues been resolved or are you still having trouble hearing?
I can hear it through her computer.
But not through yours? Okay.
Wait, what's the ionic formula for chlorate?
Chlorate?
It's ClO2.
Is it right?
Wait, is it C? What's the ionic for?
Chlorate is ClO3 minus. ClO3. You forgot the L.
You wrote carbon.
Any of you guys done already? If you are, give me a thumbs up, just so I see that you're finished.
What's aluminum?
Okay, you guys are still working?
Oh wait.
What's aluminum?
Oh, nitrate. What's nitrate again? NO is
Nitrate?
yeah, nitrate.
NO3.
NO3
Minus one. Minus one.
Yeah, you don't have to put the one.
Minus one. And don't forget look at your ionic charge when aluminum ionizes that metal. What would that be? Look on your periodic table. What's aluminum?
3. It's 3.
Write it. Make a note to yourself.
What was 3?
Right? Above it, you're making notes to yourself. 3 plus. You see an issue. That's aluminum, not ammonium, right?
Yeah, it's A.
Aluminum.
Yeah.
So how many chlorides does it take to balance an aluminum?
Oh yeah, that's right. O2. Is it roll? I think you every last one.
Hey, Greg?
Yes, sir. I'm trying to print out some, get some for them.
Do you want them to go ahead and figure out what their ratios are here?
Okay.
Or do you want them just to kind of parse it, but not what it's supposed to be yet?
No, I want you right now. So ultimately, we want to have the actual formula down below. So there's a 3 plus there and a 1 on the other one. We're going to cross the 3 down below. So it's going to be Al, ClO3 in parentheses 3.
Yeah. So I can coach them on that.
Okay, that's literally all I want. I want to be done right there. And you're on screen right now, so be your best.
The chlorate is a one thing. It's a chunk. The polyatomic ion. It's a chunk. And this chunk has an ionic charge of what? -1. How many? What's the power ionic charge of aluminum? So how many of each one of these it will take to make a unified happy marriage? Right. And so how do I do that? What's the rule? How do I do multiple polyatomic ions in a compound? Correct. Nice. Did you see who was doing that? Your soccer players. You're doing awesome. So I'm gonna give myself a little space here because I'm gonna need to put parentheses in here. And I need to have 3 of those to overcome the power of that one aluminum. It's got a 3 positive charge. Does that make sense? So this is my crisscross that y'all were doing before. Except I've got to remember because it's a polyatomic, the whole thing you have in your mind. You have to think of the whole thing as one chunk. You can't like stick a 3 in here somewhere because now you're changing it. This always travels as a ClO3. ClO3, ClO3. Always stays as a ClO3. And then if I have more than one, I show that with exactly like Mr. Mazel was saying, I use my parentheses to capture all of that. Okay. Now I want you to do this one. In the same way that I did this, I want you to kind of play with this so that makes sense. Give it your best shot. So think about the crisscross.
Would it be MN3? MN3? I don't know if this is right, class.
What's the charge in the NO3 right now?
Oh, 1.
1, right? So that 1's going to cross over for the Mn. What's the charge in the Mn2 plus?
One chunk, right? The whole thing.
What? But what? Right.
Let's see what you do.
And it's a two outside. Oh wait.
Oh, it's starting to happen.
Oh
Keep
yeah.
starting to get
it's
it.
like-
Boom.
I get it.
Good. All right, I'm going to help you out on the right-hand side because we don't have a ton of time here, and I want to make sure we do it. So on the left-hand side, you have NO3 in parentheses 2, and you have adding that to AlClO3 in parentheses 3. On the right-hand side now, don't you have an Mn2 plus and a ClO3 minus? It's almost going to look exactly as what you did with the MnNO3 on the left-hand side. Caroline, can you write on the right-hand side underneath the Mn? Can you write MnClO3 in parentheses 2? And then lastly, we have Al3 plus and NO3.
Wait, and then NO.
I can't see through you, so I can't really see what you wrote. Right. Now, here's the thing you need to be aware of here. When you actually write your final formulas down, we always exclude the charges. So let's write an overall synopsis from the left-hand side to the right so we can see everything that's included. Start on the left with MnNO3 in parentheses 2. And then let's write the whole thing out so we can see it all in order and without the charges in it. So write it right next to each other. So MnNO3 in parentheses 2.
No charge. Don't take
Okay.
clean. Plus.
Plus AL. 3.
No charges, right? So just going to write AlClO3 in parentheses 3.
Beautiful.
An arrow. And then you write the formulas on the right-hand side as well. Again, not including the charges.
Do I write that over 3, right?
I can't see what you're writing here. So just like you did above, MnClO3 in parentheses 2, right? 2, you made that 3 for some reason. Look above it. ClO3 in parentheses 2. That needs to be 2.
Oh, okay.
Yep.
So yeah, for the chlorate, it's ClO3. There's no argument.
And so that Al3 plus on the top, that 3 needs to cross over to be down next to NO3 on the right. So get rid of the 3 next to Al and put a 3 on the outside of the NO3. Okay. So really quickly right now. Now let me do a proof of concept here or idea. Do you realize if you don't know what your polyatomic ions are, that's going to make this a really nightmarish thing, right? So you absolutely need to know what your polyatomic ions are. If we take a look at this right now, is this a balanced overall set of equations? And what we can do is we can treat the polyatomic ions as a group. So let's start one at a time. So can you put your finger on MnNO3 and the parentheses 2 on the far left-hand side? Everyone watch right now because I'm going to kind of tie in balancing for you. So we're going to see how many of each thing we have on both sides. So how many Mn's do we have on the left-hand side? 1. How many on the right-hand side? 1. So we're good with that, right? Now we could treat NO3s as a group, as a unit, a chunk, like Mr. Kelly said. So how many NO3s do I have on the left? Put your finger on the NO3 on the left-hand side here, Caroline.
Yeah.
Okay, how many of them do we have? What's the number on the outside of NO3?
2.
2. So don't we have 2 NO3s on that side? Look on the other side. How many NO3s do I have?
3.
3. That's not balanced, is it? So if we have 2 NO3s on one side and 3 NO3s on the other side, do you guys know how we do the common denominator to end up with the same number? Shouldn't we multiply the one on the left by 3 and the one on the right by 2? Does everyone see how we do that?
Add 3 after the MN.
So you have to use coefficients only.
For the whole thing. Don't forget that.
Put a 3 in front of the, no, hon, go back to the, we don't have to rewrite the equations. So on top, right in front of the Mn, in front of the Mn, 3. Now that means that's going to apply to the entire NO3. So if you put your finger on the 3 right there, and then put your finger on the 2 on the outside of NO3. Another finger. So put both fingers, one on the 3, one on the 2. See, that's 3 times 2. That means we have 6 NO3s, right? Now go to the other side where there's an NO3, far right-hand side. Okay? Put your finger on the 3, right? If we put a 2 in front of the AL, you put a 2 in front of the AL. Okay, put a finger on the 3 and a finger on the 2. Isn't that 6 as well? So then we have 6 NO3s. So see how we've balanced off the NO3, but now go back to the original equation. See it? Put your finger on the 3 in front of the MN. Before, didn't we have 1 MN on both sides? But now we put a 3. So now how many MNs do I have there? Feel free to type it in here.
3.
Don't I have 3? So watch. Do you see how when I put the coefficient of 3 in front of the MN NO3 in parentheses 2, that changed the MN's balance because now it's no longer balanced. So what do we do on the right-hand side now? If we have a 3 in front of the MN right here, wouldn't we have to put a 3 in front of the MN right there? Seriously? Okay. That is all for today. I will see you guys next class period. No homework except for studying for the quiz. Drop out of this. Thank you guys.
Bye, thank you.